Hello, welcome. My name is Luke Francl, and I am a front-end testing skeptic. So this is the story of how I learned to tolerate front-end testing, and so you can follow along with my journey. Now, what do I mean when I'm talking about front-end testing? I'm talking about full-stack integration testing, including running the JavaScript that's probably part of your application. So by the end of this talk, you'll be able to set up pure Ruby front-end tests that are fast and reliable most of the time, and can become a valuable part of your, and the truth hurts sometimes, they can become a valuable part of your workflow. So when I started doing front-end development, testing JavaScript looked a little bit like this. So naturally, we tried to avoid doing JavaScript as much as possible. We tried to push as much as we could onto the server and test it there, where we could be confident that our code would actually work. And this had kind of a corollary in developing native GUI applications, where you would have your models and your views and your controllers, and you would try to keep your view as a thin as possible layer on the top of your application, because with most native toolkits, that was just pixels, right? It was very hard to automate this part in a reliable way. When I was researching this talk, I went back to the C2 wiki, and I was looking up what they said about GUI testing. And you go through pages and pages of stuff, and it's like, there's nothing that's really satisfactory. But below that level, you could have system tests that test the whole rest of the application, and unit tests that test your models. And those were reliable, and those could be repeatable and automated. And when we started developing web applications, we had the same sort of situation where you've got your models and your controllers on the server side, and you control that. And then up at the top, you've got your HTML and your CSS and your JavaScript, and that is hard to test. But in between them, we have this wonderful abstraction of HTTP. And so you could do full-stack tests using HTTP, pretending to be a web browser, basically, because the web browser is just talking at that level, too. But the other nice thing about this, as opposed to a classical GUI application, is that HTML, CSS, and JavaScript are all just text. So we can actually examine them. We can look at them and see if they are matching what we were looking for. But since I came from this background of trying to avoid JavaScript as much as possible, I never really saw the cost-benefit analysis being there for testing, for doing this kind of front-end testing. So I wanted to keep it at the HTTP level and below. But things have changed. As Paul Graham put it when he was talking about Ajax and Web 2.0, JavaScript works now. JavaScript has become, in the last 5 or 6 years, like a huge part of our applications, to the point where entire applications are written basically in JavaScript. And this is pretty amazing, and it's allowing us to do some incredible things with our applications. But this old way of testing needs to catch up. So for me, there were 2 things that caused me to sort of rethink my position and come to grips with coming up with a good way of testing this front end. The first was that I started working at a startup called SwiftType. So SwiftType provides search as a service, and in addition to our developer API that lets you index and search for content with a REST API, we also have a consumer type of product where we give you a JavaScript embed, and you can just put this into your template of your code, of your website, and it will enhance your search box and give you a full-featured modern search experience. And the way we do that is by injecting JavaScript into your page. Here's a demo of how that works from my blog. So you can see here you type into the search box, you get autocomplete results. If you click on one of those, you'll go directly to it, but you can also get the search results in a list as a traditional search results. And this is all done through client-side JavaScript, third-party JavaScript. If you are interested in doing third-party JavaScript, I definitely recommend checking out this book written by two of the engineers who wrote Discuss, which is a commenting system you may be familiar with. So this will give you some of the tips about how to do this in a reliable way. But the trouble with doing third-party JavaScript is that you're executing in an environment that you don't control. So the page that you're in can be setting variables that you need to make sure aren't interfering with your variables. You need to make sure you're not exporting global variables and screwing up their content. It's a very constrained environment that makes it hard to develop for. And so we wanted to make sure, as we develop this product, that we're not going to break things. So we've been growing a lot, and we, as you can see from this graph with no y-axis, we've been growing a lot, and so we're putting this JavaScript onto tens of thousands of web pages, hundreds of thousands of times a day, and so it really needs to work. But this graph is really not the one that scares me. This is the one that scares me. Total number of search engines. Now, not all of these people use the third-party JavaScript, but a lot of them do. And I have to help answer the support requests for this. So if we break this JavaScript, we're going to hear about it, and it's going to be really painful for me. So I want to make sure that it works and doesn't break. Now, the specific project that led us to come up with this solution was that we, at SwiftHub, wanted to improve our mobile experience. So we came up with this design where if you're on an iPhone or an Android phone and you're using our JavaScript embed, we give a mobile-optimized search results. So we had to add this to our existing code. And in the meanwhile, we also wanted to remove some duplication and make the code smaller and nicer and refactor it. But, oh yeah, it needed to continue working. So if you're not running JavaScript, this is really hard to test, to the point of being impossible. You're going to be loading it up like we used to. You're going to be, every time you do a deploy, it's like, load it up in all the important sites and make sure it's still working. And that's no fun. So the second thing that led me to kind of rethink this client-side JavaScript testing thing is that the tools are so much better now. When I started looking at JavaScript automation, the state-of-the-art was Selenium, and it would record your clicks and then replay them by launching Firefox and going through it. And it was really slow and painful and prone to breaking, because anytime you change something on your web page, all your scripts break. So I'm going to be talking today about 3 tools. The first one is Capybara, which is a framework for front-end acceptance testing. So it gives you a DSL for interacting with the DOM. The second tool is Phantom.js, which is a headless WebKit browser. So unlike old version Selenium, it doesn't start up a browser and click through things while you're watching. And it doesn't require a frame buffer. So it starts really quickly, and it's super easy to install, including on your CI servers. And then the third tool is Poltergeist. So Poltergeist is the Phantom.js driver for Capybara. It's the Ruby code that ties the two together. One thing I'm not going to be talking about is Cucumber. I don't really understand Cucumber. If you like Cucumber and you're being successful using Cucumber, more power to you. But as I said, I don't really understand it, and it's not necessary to test front-end code. A lot of examples you see, it's like, we're going to test some JavaScript. First step, set up Cucumber. And that's totally not necessary. But if you find it useful, you certainly can use it. So in order to demonstrate these techniques, I decided to write a sample app, which you'll be able to download from GitHub. So what it does is lets you type ahead the names of a country, and get a list. And it uses Twitter's typeahead.js library, which is a really cool library for autocomplete. So here's how that works. You just start typing countries, and it autocompletes them. You can click on one of them to go to it, and then when you do that, you'll end up on the page for that country. So this is the example we'll be using as I go through these tests. So first step, install Phantom.js. Super easy if you use Homebrew, brew install Phantom.js. It's done in a few seconds. Next up, you'll need to add Capybara and Poltergeist to your gem file. In this example, I'll be using RSpec, but obviously if you prefer Minitest or something else, you can use those instead. And down at the bottom here is the URL for this GitHub repo. Finally, you need to tell Capybara to use poltergeist. And so here's how you do that. What I'm doing is I'm registering the driver named poltergeist. And there's a couple things that I'm doing here that are not the defaults for this. One is that I have this JS errors true option set. And the second one is the web inspector, or inspector true. So what JS errors true does is it will fail your tests if there's a JavaScript error. And the other one is a web inspector. So you can actually connect to it and debug your tests live as they're running, which is super cool. And then the final thing I'm doing down here is I'm setting the JavaScript driver to poltergeist. Now, the reason it's just setting the JavaScript driver is that Capybara's default behavior is not to run JavaScript. It uses rack test, and so it's a lot faster if you don't need to run JavaScript. But if you do, then you will use the JavaScript driver. So what's the simplest possible test that will demonstrate value for you in your application? I think it's this right here. So what this is doing is it's visiting a path on your website, and it's filling in something on the page. And all this is doing is that it will throw an error if the test, it will fail the test if a JavaScript error occurs. So you can imagine there's probably times you have deployed to production and missed some page on your site, maybe some important page on your site, and there was a JavaScript error on there. Maybe you left a console log in there or something like that, right? This will catch that, and that is a really cool feature. One thing to note about this is that I am setting JS true here. As I was saying on the last slide, we've registered poltergeist as the JavaScript driver. So anytime I want to use JavaScript, I have to pass this JS true. Before we go deeper, let's look a little bit at the Capybara DSL, some of the things you can do. So first of all, you can visit a page in your application. You can either use a string URL or you can use your Rails routes, which is really handy. Then you can click on things. You can click on links or buttons, and you can do that by the name or the text on the element or by the ID. I think long term, using the ID is better because it's less prone to change. This test here would fail if you change login to login here. But if you're using the ID of the button, then it's not going to break. You can fill in forms. So in this example, I'm filling in the form field with the label username with the text RailsConf. The next two lines are interesting because I can assert that the page has elements with a CSS selector, and I can find elements with a CSS selector and do something with them. And the reason this is interesting is one of the things that makes Capybara a really useful tool. What this is doing is actually retrying over and over again until this becomes true or a certain timeout is reached. And the reason that's important is because if you're using asynchronous JavaScript, your DOM is changing out from underneath you, right? So it may not be true the instant your test runs. You're clicking a link and then something is going to your server and then it's changing in the page. And so this allows you to test that kind of behavior. The final line I think is also really interesting. You can evaluate JavaScript inside Phantom.js and then return the result to Ruby. So here I'm testing whether or not the JavaScript expression, the number 1, is equal to the string 1, which, although one of JavaScript's stupider features, is true. So this can return simple values. Like you can't just return a JavaScript object and have it marshaled to a Ruby class or something. But if you've got arrays or strings or numbers, it can do that and can be a really powerful thing for your tests. All right. So the next couple tests I'm going to talk about are for the example app I showed you. And I'd like to look at how the DOM for that page is so that we'll have a context for understanding the test. So this input country line here that you can see, that is the base HTML of the page. That's what I started with. And then by adding the Twitter type ahead library, all the rest of this stuff got added. So it includes everything in this Twitter type ahead span. And then underneath the input, there's the TT drop-down menu and the TT dataset countries, which is the name of the data. And then inside that, there's TT suggestions and the individual suggestions. So if I'm typing AF, Afghanistan is going to be one of the TT suggestions. And if I type something that doesn't match any countries, the TT suggestions isn't going to have any children. So that's just try to keep that in mind as we look at these next tests. So this is a slightly more complicated test. What we're doing is we're visiting the home page. We're filling in the country field with NORW, which is short for Norway. This next line is a hack, and I'll talk about that in a second. But after we click on the body, I'm finding the TT suggestion. So this just finds the first one, and then I'm clicking on it. And if you remember from the video, what that does is takes you to the page for that country. So I'm asserting that the current path should equal the country path for Norway. Now let's talk about this hack. This is actually interesting because as I was developing this sample app, I ran into this test failure. And so it's saying that the element wasn't found, TT suggestion, because there were no suggestions. I was typing in Norway with Phantom.js, and I wasn't finding anything. Well, debugging is never fun, especially with JavaScript tests. But Poltergeist and Phantom.js make it a lot easier. It has this amazing feature called page.driver.debug. And what this does is it launches the web inspector. Remember that how I said inspector true? So this will launch the web inspector and allow you to navigate through the DOM of the actual running test. It's just like doing debug in your tests in Ruby. That launches you into a IRB console, and you can check out the local variables and stuff like that. So here's a video of how that works. This shows how I figured out what was wrong with that test. So you can see this is just like Chrome or Safari's web inspector. You can look at the DOM. There's the form. I'm digging into it. Inside it, you can see the Twitter type head span. And then down here at the bottom, there's the TT drop-down menu. And there's something wrong with it. It's display none. Why is that? Well, it's probably because the way that the Twitter type ahead library decides to show the results is probably based on some sort of on-click or on-key-up event from the browser. And the way that I'm filling in that field isn't actually triggering that. So I added that hack to actually click on the body, and that caused it to display. So this is like a super powerful tool for debugging your tests. And sometimes, since it isn't exactly like a browser, you may have to make some adjustments like that. Another thing I think is really important is testing the negative case. So a lot of times people just test sort of the happy path. Like you test that, oh yeah, I typed in Norway and I found Norway. But you need to make sure that you're also testing negative cases. Like in this case, I'm typing in ZZZ, which should not match any countries. And in order to test that there were no suggestions for this, I'm going to take advantage of this evaluate script feature. And so what I'm doing is I've got this string of JavaScript, and all it's saying is that I'm using jQuery here. TT suggestions has no children. And so if I evaluate script, that should be true. And it is, which shows you the power of being able to just use JavaScript in your tests. Another thing that's really important to us at SwiftType is to make sure that we're not leaking global variables. So this is an example of an RSpec matcher that we wrote to test for that. So you can imagine you're clicking on some sort of AJAX thing, and then it's doing something, right? And it's running a function. Well, what if somebody forgot to declare their variable in that function? This kind of test will catch that. And here's how it works. So this is a sort of simplified example from our code base. What it does is we have this string, globals.js, and that's really a string containing a JavaScript function. And that function is pretty simple. It just iterates over a window to see what properties it has. And so I capture that array of names, variable names, in before globals. Then I call the proc.call. So the proc is the block that was passed in to expect. And then in after globals, I run it again. and I subtract them to get the difference. And this matcher also has an argument called allowed. And what allowed does is allows you to say, oh, well, I'm going to add this property to the window, and that's expected. So I take those out of there as well. And then the test will fail unless that difference is empty. So this is going to catch any kind of situation where a programmer is leaking global variables. And I think that's a really interesting thing that, this may not break your application, but it's really, it's bad style to do. So this is a simple thing that you can do in your application today to ensure that you have good JavaScript style. Another thing that I think is really interesting with testing this approach is testing cross-site scripting. So, we hopefully all follow best practices. We're using Rails is now secure by default for cross-site scripting, but there are cases where you want to display HTML from the users, right? And so this will make sure that those cases don't allow cross-site scripting to be used. So what I'm doing is I'm creating a document, and I've intentionally added some script tag to it. My test, on the other hand, visits that document and then makes sure that the content of the title, imagine you have a template that's outputting this, right? It ensures that the content of the title is exactly equal to what I have set in this let block. And what that means is that this script tag was escaped. Because if the script tag wasn't escaped, it would be evaluated, and it wouldn't be there anymore. And so that wouldn't match. And then the second line also does that. It evaluates a script to check the value of window.xss. So that's what the attack is doing, right? So that should not be true because it shouldn't be set. So this is something that's really important to get right. You need to have secure applications. And just because you are following best practices and your co-workers are following best practices doesn't necessarily mean that 2, 3 months, 4 months, 6 months down the line, somebody isn't going to add a problem like this. And if you have a test like this, it will catch it. And unlike testing through the Rails stack, you're actually evaluating these cross-site scripting attacks to see if they are working or not. So just to sum up this part, you may not be injecting third-party JavaScript in hundreds of thousands of sites or whatever, but you probably have a flow in your application that's using JavaScript, right? Like maybe your login. When you log into your app or sign up to your app, you have a username checker, right? And it's checking to see if your username is available. And you may not be testing that all the time because you already have an account, and so you're not on that page a lot. Unless you're running your JavaScript tests, you can break that really easily and get that deployed to production. I mean, has anybody deployed broken JavaScript to production? Yeah, I mean, I think we all have, right? So if you test your most important flows, you won't be looking at your growth graph and being like, oh, my projector died. So you won't be sitting there looking at your growth graph wondering, geez, why isn't anybody signing up for my app? So therefore, you should test those important flows. I mean, I'm not saying that you should be testing JavaScript on every single aspect of all your pages, but the important parts of your app, I think, really deserve that testing. So I think we see now why the screen was going orange. But I was at a conference in Portland earlier this month, and this guy's presentation totally died. Like, his computer crashed or something. And it was amazing, because he just gave the best talk I have ever seen. And the best part was he just got his laser pointer out, and he's like, up here, I'd be showing you what's going on. So I'm going to soldier on. All right. So the next thing I was going to talk about is kind of the gotchas about this. So you've heard the good parts, right? But it's not all roses. Like, these technologies have problems. So I'll talk about three problems that we ran into. The first problem was waiting for stuff. So as I was saying, Capybara will wait for things to change on the page. And that works a lot better now than it used to in Capybara 1. So before in Capybara 1, we would, we'd be loading up our JavaScript embed, and we'd have a lot of things going on the page. But in our tests, we'd have to be like, okay, wait for this to happen. Okay, wait for this to happen. Okay, wait until this happens. And then click on this. Okay, screw it. I'm just going to sleep. I'm going to wait. And that has gotten a lot better. In Capybara 2, those problems are almost entirely resolved. The only problem that sort of still remains is if you're waiting for some sort of JavaScript thing to become true. Like if you're evaluating a script, because that doesn't work the same way with the finder waiting until the timeout is expired. And there's a guy named Kyle Vanderbeek who wrote a good blog post about this, talking about how he wrote some helpers for Capybara that synchronize JavaScript and synchronize jQuery. So what those do are they apply this. Well, Capybara now has this method called synchronize, which will apply this retry logic. And so what his code does is it synchronizes, and then it evaluates a script over and over again until it becomes true or the timeout is expired. The second big problem that we've run into is Phantom.js crashes. So can a ghost die? Like, does that even make sense? I don't know. But it does happen. And if it's repeatable, well, then you can file a bug report. But if it's not repeatable, you just sort of like forget about it. So I would say maybe like 1% of the time our tests will fail, and it'll be because of a Phantom.js crash. So it hasn't been a deal breaker for us. It's just something that's like, oh, the build failed. Oh, it's Phantom.js again. Okay, whatever. So you just kind of live with that. The third problem is about transactions and database setup. And if you could see my slides, you would see that I have a quote from the README manual, which we probably should have read. So we actually use MongoDB. And MongoDB is not really transactional, right? And so the problem with transactions in Capybara is, and the problem with transactions in, ooh, pretty. The problem with transactions is usually that, oh, yay, awesome. So the problem with transactions is that Capybara, when you run a JavaScript driver, actually starts up a copy of your Rails app in the tests. And so it's in another thread, in another thread. And so the browser is running, the fake browser is running, connecting to that real version of your Rails app that's connected to your real test database. And so the problem with a relational database is usually that the way that Rails fixture loading works is that it rolls back after every test completes. And so with Capybara, it'll roll back before it has a chance to actually see the data. But with us, what was happening is that we use database cleaner, and it just wipes out the database in between every test run. And so the test would be running, and RSpec randomizes test order, right? So depending on where in our test run our Capybara test started running, all of a sudden tests would start failing, and it was really weird. Fortunately, with RSpec, you get a seed, of the random order, and you can go back and recreate that. And after a bit of digging, I was able to figure out that the problem was actually this Capybara starting up a server and talking to the same test database at the same time. And the fix, once we knew that, was really pretty simple. What we do is we run all our tests that don't require JavaScript. So our standard Rails unit tests, our standard Rails controller tests, and any Capybara tests we have that use the rack driver. Those all run first in our normal test run. And everything else that's using JavaScript runs second, like as part of another process. And so they don't interfere with each other. All right, so that covers the gotchas, and I've talked about how we're using it. Now I'd like to talk about what we are looking at next. These aren't things that we're doing yet, but I think they're super interesting. So one of the next things I'd like to look at is JavaScript unit testing. We are not actually doing any of this yet. But there's a couple of frameworks out there that look pretty nice. This example is Jasmine, which was created by Pivotal Labs. There's also QUnit, which is a jQuery project that they use for testing jQuery, and another one called Mocha. So the downside to these tools is that you need to load them in a browser to run the tests. This is a Jasmine test runner example. What it is doing is running the tests, and the way that you do that is you reload the page. But we have this great headless web browser. So can we get it working in our regular tests in an automated, repeatable way so I don't have to load up my web browser to run my JavaScript tests? Yes. And this gentleman, Matthew O'Riordan, wrote one of the most epic blog posts of all time describing how he got all of this working. And I'm just gonna have it up here and scrolling as I talk about it because this page is huge. But what's great about this is he went through a lot of the stuff that I've talked about here today, and I relied on this post a lot when I was setting this up. He went through all this, and he talked about what worked and what didn't and the problems he ran into. And at the end of it, he gets all this stuff working, and then he adds automated running of his JavaScript unit tests. And the way he did it, I thought, was really clever. He has a controller with an action that's only hit in his tests. And the way that that works is that the action is a JavaScript file, basically. And so he loads that action with each JavaScript test file that he has. And so he can get like individual test failures for all his JavaScript, which is awesome. And I thought, I should set this up in my test app for this talk. But then I found out about ModeSet's Teabag gem. Great name, guys, thanks. So this does all that stuff except you just do gem install Teabag and you're done. It's really cool. And it's really cleverly thought out, too, because he uses the asset pipeline as a way to, or all these tests run through the asset pipeline. So in your JavaScript unit test, you can actually include files with sprockets that you're testing, which I thought was cool. So this is how it works. This is an example of running some tests with Teabag. And what it does is it starts up a server, and then it uses Phantom.js to hit that server one at a time, like Matthew's example. And so you get individual test failure messages, and you can debug them. You can run just one file or everything. It's actually really nice. And since we're not actually using this yet, I just added a couple examples of it into the example app that you can find on GitHub. So I definitely recommend that you check that out. One of the other things I'm really interested in is perceptual diffs. Can anybody tell me what the difference between these two rectangles is? Can anybody tell? Yes. One of them is slightly bigger. And I believe it's the one on the right. So this is the perceptual diff generated with the program called pdiff that shows the difference. That red part is the difference. And I can prove it by overlaying them. So you can see that part is just a little bit bigger on the one that went on the bottom. So I got this from Brett Slatkin, who works at Google at on the Google Consumer Surveys team. So their team is using perceptual diffs for automated testing and continuous deployment. And he says that for them, perceptual diffs are the thing that makes continuous deployment work. So here's another quiz. Who can tell me what is wrong with this web page? Like, what is not working here? Well, besides the pink. The answer is actually this chart. You can see the actual result over here. The axis is all screwed up. And on the right, the axis is how it's supposed to look. And that's really hard to tell. If you look closely down at the bottom, you can kind of see it, right? So you can imagine like you're just doing a once-over on your app real quick before you deploy. You push it out. You don't notice it. But the computer notices this right away. And so they get this perceptual diff in the middle, and they get those results emailed to them and are able to look through them and be like, oh, yes, I meant to change that, or hey, what is that? And I think that's really powerful. And for us specifically at SwiftType, it would be amazing if we could load up a new, like the expected version of our jQuery of our JavaScript, third-party JavaScript, onto a site, do a search and screenshot the results, and then load up the new version, do the same search, screenshot the results, and compare them, and make sure that they're actually the same. That would be a very powerful tool for us and would save us a lot of time. What I've talked about so far, is kind of assures us like a baseline of functionality isn't breaking. But what this would allow us to do is be a lot more aggressive with pushing out changes to the JavaScript and not having to test them manually so much. So I think that that's really cool. Brett Slatkin's working on an open source project to make this possible for any project, and I'm really curious to see how that develops. All right. So to review, we've seen why front-end testing has become a necessity, because more and more of our applications are written in JavaScript. More logic is moved to the front end. And we've looked at how Capybara, Phantom.js, and Poltergeist can be used to make front-end testing, if not enjoyable, at least less painful. And we've introduced an example app that you can take home and you can adapt to your purposes, your own projects. And we've shown how to debug test failures in that app. So have I convinced you? I don't think I'm ever going to love front-end testing. But with these tools, it's become a really valuable part of my workflow. And it's really helped to keep Swift types JavaScript code running smoothly. Thank you.